Next, it's our bonus feature segment. Thanks for tuning into the Daily Space Weather. The first thing we're looking at is the total electron content forecast. And we're seeing quite an elongated electron band here. So a little bit of chaos still happening here in the inner Van Allen belt and plasmasphere. Lots of free electrons that are sort of out of place. And this is a typical thing that we do see during coronal hole high-speed streams. Although we see that stream subsiding, we can expect this to become a little bit more orderly and a little bit fewer GPS errors happening at nighttime around the equator. Your total electron content forecast is showing you the free electrons in between a GPS satellite and your handset. So those satellites are located at about 12,500 miles of altitude. And when they have to communicate through a lot of electrons, they tend to send erroneous data about your location. We've also got some charging hazards here over the southern Indian Ocean, even the Atlantic Ocean. A large band of internal charging here. That's from the higher speed, higher voltage electrons making their way into electronic parts and causing them to become charged up. So that can cause some communications failures and so on, folks. That's about what we expect. Here's the one-year chart to put that in context, the one-year chart of the electron flux. And here is the 3-day chart. You see we got well into warning levels. And we've remained in warning levels even through midnight. So these arrows, right, these M's and M's, that's noontime and midnight local time for the GOES 16 satellite. A geosynchronous near equatorial satellite orbit is what the GOES 16 and 17 are doing. Here's the forecast. We're expecting a peak in the electron flux here following the subsiding of this coronal hole wind stream, which looks like it's happening as we speak. Next, we're going to show you what's going on in the ionosphere. Here's your ionogram for the F ionosphere layer, located at about 300 kilometers of altitude. Things are looking fairly orderly to me at this moment. For the past day, that's what we're showing here is the previous day. Some high-frequency anomalies happening in the southern hemisphere there, but mostly pretty orderly there on the ionosphere. Let's show the anomalygram next. Here's the anomaly from the 30-day median. That's anomaly in megahertz, showing high frequency in blue, low frequency in red. Not super chaotic in the ionosphere at the moment. And here's the latest image. That's the ionogram in showing vibrational frequency in millions of vibrations per second at 11:45 universal time, and there is 11:45 universal time the anomalygram. No major anomalies, but some minor swings happening here around the Central African continent. We've been seeing those for quite a while now. Next, welcome to the Neo Renaissance. Congratulations on realizing the channel exists. Please visit our website, support the channel via becoming a member of the Smash Team at smashandmash.com/Smash Team. Here is a little teaser. We replaced Patreon with something superior, our own website subscription services, and showing some additional content to gold and silver members. If you're not on Twitter, get on Twitter and follow us. Why? Because, well, first of all, we've only got 206 followers on Twitter. But secondly, we're putting up shared tweets. So what's great about Twitter is that as long as you don't get banned from it, you'll see information that is quite interesting. So this post from Dr. Erica Palmario, we've invited her to come on the channel to explain some modeling about coronal mass ejections, as we were not aware of this clockwise rotating ejection being associated with the southern hemisphere. So again, check us out on Twitter. We shared the tweets. We've also got all kinds of links to stuff you'll only see on Twitter. You need exclusive content on your different social media sites. Twitter.com/SmashOmash. And here comes some additional bonus features. It's the ground-based solar observatory at El Teide, Spain. So you can see these filaments, and you can see some flaring. You can see some brightening happening here behind sunspot 2939. Also, this huge filament that we covered in depth yesterday is still hanging out here around the southeast limb. We've also got a new sunspot group formed right around this area. And let's show that. So here's a new sunspot group. It's already beta class. We'll be interested to see what the growth of that is, if any. We'll also show you the colorized magnetogram. Sunspot 2939 still has quite a few complex fields around it. 2940 still capable of producing large flares. And 2941 is the star of the star. It's the most magnetically complex sunspot group. It's most likely to produce large flares. It's beta gamma class. 2941. Here's 2940. Here's 2939. And this one is likely to be called 2942. Let's close things out with some 304 wide field of view GOES 16 SUVI images. So lots of filaments still hanging out there. You can see around the southern portion of the closest star. Major plasma filaments there. That's ionized helium, if you're wondering. This is ionized iron. It's 94 angstroms from the SDO. A little higher resolution, a little narrower field of view. We can see some flaring here still occurring from the area around sunspot 2936. See some brightening there around the limb. And the 94 angstroms is one of the best wavelengths through which to view solar flares. Keep an eye on sunspot 2941. We'll close out the bonus feature segment here with our 171 angstroms SDO imagery of the full disk. Once again, thanks viewers for tuning in, and may that solar wind be at your back.